to start with today. And the way that I start with properties of exponents is that I use the number 2. We all know how to work with the number 2. Occasionally, yes. So what I start with usually is, well, let me show you. What is 2 to the first power? 2. 2 squared. 2 to the third. 2 to the fourth. 2 to the fifth. 32. Basically, all you're doing is multiplying each one of them by 2. Okay. Now, going the other way, what are you doing? You're multiplying by 2 as you go down this way. Going this way, you are. All right. So that means what is 2 to the 0 power? 1.
2 to the negative first time is 1/2.
Correct. 2 to the negative 1 would be 1/2.
2 to the negative 2 is 1/4.
Correct.
1/8, 1/16, 1/32.
There you go. What's happening here, what happens here, as you are going up, you're multiplying by 2. As you're going the other direction, you're dividing by 2. So each time you're dividing by 2, you're cutting something in half. So what's half of a half? A fourth. What's half of a fourth? An eighth. What's half of an eighth? A 16th. Half of a 16th, 32nd, and so on and so forth. So you get this whole idea of being able to work with your exponents. Now, that also means that you can also multiply and work with these things. For example, if I wanted to ask what is 2 to the third times 2 squared? It's 2 to the fifth. Because watch what happens. What is 2 to the third? What's 2 squared? I wrote 2 to the fifth, like 2/5. And this is 8 and this is 4. What's 8 times 4?
32.
Nope. Yeah, next one. So you get all these different rules. You get a ton of rules. For example, if you have the same base, different exponents, and you're multiplying together, all you do is add the exponents. Okay. If you have the same base, well, let's think of it this way. What happens if you raise it a power to a power? Well, go back to the idea of 2 squared, and if I raise that to the third power, order of operations tells you what to do first. No. Parentheses. Inside the parentheses, I have 2 squared. What's 2 squared? 4. So this would be 4 to the third. Well, 4 to the third is how much? But 16 times 4 is 64. Now that's the same thing as saying 2 to the 6th. So when we have what's called power to power, you multiply. Power to power. These exponent rules will not go anywhere, guys. We'll have fractional exponents here a couple of months also. Okay. Anything to the 0 power is always 1. Okay. When you have two to the fourth divided by, let's make this simple, 2 to the fifth. 2 to the fifth divided by 2 squared. How much was 2 to the 5th? 32. And then 2 squared is, what's 32 divided by 4? Which is 2 to what power? What happened with the exponents? Subtract them. But here's a kick. We don't want negative exponents. So whenever I have a division set up, what we're always going to do is play war. Which exponent is bigger, the 5 or the 2? So it's going to be, that means that 5 wins, so it's going to be 2 to the 3rd up top. Now if it was 2, let me show you this. So if it is x to the m divided by x to the n, I'm going to say play war. Okay? What that means is if I have 2 to the 5th over 2 cubed, the 5 is bigger than the 3, so it becomes 2 to the 5 minus 3 in the numerator. I get 2 squared. If it was in the denominator, which one wins, a 7 or a 3?
7.
A 7. So then it becomes, very good, 2 to the 7 minus 3, which is 1 over 2 to the 4th. Okay? That's how you always keep exponents positive. Because negative exponents aren't our friends. We don't like to surround ourselves with negative people. We like positive people. We like people that help us. We like people that, oh, I'm full of crap today. So, anything to the negative power, make them happy, send them to the other side. If they're not happy in the numerator, they'll be happy in the denominator. And if they're not happy in the denominator, where are they going to be happy? In the numerator. Anytime you have a negative exponent, it just jumps sides. Numerator to denominator, or denominator to numerator. That's all it does.
Mr. Jenkins says that he would be unhappy until
Right, that's basically the same idea. It's unhappy, make them happy by moving. Get out of here, jerk. Go be happy somewhere else. Now they're happy. Okay? What? Nod and smile. A policeman and like Obi-Wan Kenobi. Yeah, Moose is the cop. I think Moose really wants to be a cop, like in real life. That's all he talks about. Power to power, power to power, easy, easy. Okay. Wait, what was? How did I write that out? I want to show you the right one. Oh, that's right. When you have two things raised to an exponent, think of this. This is a monomial here, guys, because there's no addition between the two. This is when you distribute your exponent. Okay, this is when you distribute your exponent. And it works the exact same way if there's division. Same thing, basically the exact same thing when you're dealing with it with a fractional part. Okay. Really, to be honest with you, the only trick that you guys are going to have is that you're going to forget how to add. You'll put something together too fast, and that's about it. Now, do you think, knowing me by now, am I going to give you a lot of these types of problems with numbers?
Yes.
Definitely.
I would, but then I would take away your calculator.
No.
So, think I'm going to give you? Numerical problems or variable problems? Do some.
Maybe like 9.
You know what? I don't want to do this. You guys go up and do these. Figure it out. Go. There's 9 of them. There's like 20 of you. Figure it out.
Take the easy ones
Maddie,
first.
take one for the kid.
Yeah. Quick, so let's get the easy ones.
Seriously? Can I have all the good stuff?
You want to actually do it?
Oh yeah. Jacob, take number 17. No, do number 17.
Wow, that's horrible.
No. Okay, then that's one more. I didn't know her name was.
Oh yeah, that's
I found it last night.
I did.
No, I'm just gonna I'm gonna fix it. I'm trying to figure out. Yeah, we just mean you used to do it.
I just wanted to.
AJ Freeman.
You should hear what Logan was saying.
That's why I swear.
That's why I swear.
Swear. You know,
So
we're
he's talking about
expert in competitions.
we're talking about how like on Friday like.
Not even out of high school. Gosh dang, why is it with this pen? Yeah, it's probably because we're using both.
And then he was talking about like he had a daughter who was crying. He would tell her stuff like.
I keep making an X. And when I do like
X
right here,
is
it makes
hard
it
to
like right
make.
here.
X is hard to make.
I'm not trying to make an X, I'm trying to make Y. Over.
Especially in high school.
Y squared. There.
Great minds think alike. What's in the bottom?
They're having a hard time or are they like.
Yeah, we got.
I was 58, 28 or 58, 29, I believe. So he was the guy that when I was done running, he was running past me going the other way.
You bring that one there.
So you're gonna have a daughter, or you're gonna make cry, and she can't leave the house, but you're gonna have a well, do you think that if, when she cries, it's gonna give her
That's 9 over 6. All right, real quick.
So
Let's
he
check.
was right.
Oh.
Hey, look at So he
So-
was right.
So what happens here, guys, is most of these things are relatively straightforward. What you will have to be careful with is simplifying fractions at the end, okay?
They're hard.
So, x to the 5th, 2 over y squared, 9x squared, y cubed over 8. Couldn't get away from the buffet. That was funny. 2 to the 6, that one's 1 over y squared, 5 halves. Hey, what happened to the 2 here? One thing I will remind you, when you have monomials with numbers, you always want to do this first. Take care of the numbers first. 5 over 2. There's nothing that can simplify, you leave it. All right? And then go variable by variable. X squared, x to the negative 1, not happy. Send them up, you get it at x cubed. Y cubed, wins on the bottom. That's how you make that work. So make sure you don't forget numbers. 3, negative 3, good, you didn't move that one. So you have negative y to the 5th over 3x squared, perfect. And then 9x squared, x to the 5th, yeah. So whenever you have numbers like that, always simplify fractions. Looks like a dorm page. In the world. Do these.
32 and 47.
Yes, ma'am.
Even
326, 6.1 old book. Yeah. So 6.1 OB. Page was that again?
Bring my daughter to your house.
Honestly, I would. I love this.
I'll keep my daughter over to
All of them.
Yeah, you'll fly right through. Have